Welcome back to the IGCSE video series. So today we are going to talk about the 2D trigonometry. So trigonometry is one of the very important sections in your exam because you get a lot of questions from this one. Plus, actually these questions are basically for the band 9 as I feel, because the trigonometry is a bit harder, right? So that means you get questions that can score 5 marks in certain cases, right? So the trigonometry in here can be divided into a few sections, like especially the 2D trigonometry and the 3D trigonometry. So this is connected with the Pythagoras theorem and the trigonometric ratios and inverse trigonometric ratios, and also it is connected with the angle of elevation and the angle of depression and the bearings. So in this part of the lesson I will basically discuss about the Pythagoras theorem and the trigonometric ratios, inverse trigonometric ratios, bearings, and angle of elevation and depression. All the theory sections will be covered in this session. All right. Okay, then we can discuss some questions in the later part of the video. Then we can go to the 3D trigonometry. Okay, first I will take the Pythagoras theorem as a subtopic under this 2D trigonometry. You might have learned Pythagoras theorem previously, but we'll learn this here also because having all the theories in one place will be easy for you for your studies, right? You know that we use the Pythagoras theorem basically for the right angle triangles, right? That means if you have a right angle triangle like this, I name this triangle ABC. This is the right angle, right? So the side opposite to the right angle is called the hypotenuse. This is the hypotenuse, and this side is not changing, and it is the longest side of this right angle triangle, and also it is always opposite to the right angle. No matter what the orientation of the triangle, if it is opposite to the right angle, this is the hypotenuse. So that's how you identify the hypotenuse of any given right angle triangle. You might have a different orientations, right? Like this. This is the hypotenuse again. It is always opposite to the right angle. So that's how you identify that. And also it is the longer side. Okay. Then the side AC is the hypotenuse of this particular triangle. The Pythagoras theorem is that the square of the side length AC is equal to the sum of the squares of other two sides. Sum of the squares, that means BC squared, plus sum of the other two squared, that means AB squared. AB squared. So this is simply the Pythagoras theorem, nothing else. That means the square of the longest side of the hypotenuse is equal to the square of the sum of other two sides. That is the Pythagoras theorem, right? So actually someone might confuse. So what is this AC, BC or AB? These are side lengths, right? That means if the length of this side is A, if this side is, I take this, if this side is B, and if this side is C, you can write that A squared equals what? B squared plus C squared. Sometimes you see Pythagoras theorem like this also, right? A squared equals B squared plus C squared. So this is based on the length. So these are also lengths, but here you can represent it with one letter also that is relevant to the length. Okay, hope you got the Pythagoras theorem. We'll do one question based on this one. All right, let me take this particular triangle. So if I use something like this, so I will give the length of this side is I will take like 6, and this side is like 5, something like this. You want to find the length of this side, x, the side length of x. All right. then the length x should be found. Imagine this is 6 centimeters, this is 5 centimeters, and you notice that this x is not the hypotenuse because this is the hypotenuse, right? So we'll write down the equation. I can write this is the hypotenuse, that means 6 is squared equals what? 5 is squared plus x squared, isn't it? 6 squared plus 5 squared plus x squared. So you want to find the x value, that is the length. This is a side which is not the hypotenuse, a shorter side. So we'll rearrange the equation. I can take this 5 to this side. Since this is added, it will get subtracted, and we'll expand it in the same step. 6 squared means 36. 5 squared is 25. I'm taking it to this side. That will become minus 25 equals x squared. Then you can subtract 36 minus 25. That will be 11. This is nothing but 11 equals x squared. You can take the x to this side, 11 to other side. This will be x squared equals 11. To remove the squared value, we have to get the square root of the both sides. Then x squared will reduce to x. I will write down it here. Then x equals nothing but 11 root. So you have to simplify this, get the root value of the 11, then you get the side length of x. Get the root value, use a cal for that, then you get the answer here, right? So that's how you get the answer or the solution for a side length using Pythagoras theorem. If you have been asked to find the hypotenuse, no need to make this the subject. So this is the hypotenuse itself, then you get the answer like this. Understood? So this is basically the Pythagoras theorem. And in trigonometric equations, these are interconnected. That means when you have triangles, sometimes you have to use the Pythagoras theorem first before using the trigonometric ratios, or else you have to use the trigonometric ratios first, then you have to use the Pythagoras theorem, like that. Alright, let me erase the Pythagoras theorem section. Now we are moving to the trigonometric ratios, right? So it also applied for the right angle triangles, but the trigonometric ratios will be used for non-right angle triangles later on. We'll discuss that one also in a future session, like the cosine rule and the sine rule, these things. And here we will get an introduction to the trigonometric ratios first. Okay. When we come into the trigonometric ratios, these ratios are not, introduced to the right angle. It is introduced to the non-right angles. It's acute angles of a right angle triangle. That means when you have the right angle like this, you can have another two angles which are smaller than the right triangle. It is always smaller than the right triangle. Let me name this as x. The angle name is x, and the triangle name is ABC. Okay, then I will draw another triangle. I will use the same orientation like this. Okay, this will be the triangle PQR. Then this angle I will take it as x for this particular triangle. All right. So there are two triangles, triangle ABC, and two different angles x. Right. Let me take this y. I think that's better. Okay. This is y. All right. So it can be x. It's a different triangle. All right. But we'll use it as x, as y. All right. Okay. Then there are basically three trigonometric ratios we have, and these are the sine and the cosine and the tangent. So these are the three trigonometric ratios we have: the sine, cosine, and tangent. In short, we call this sine, cos, and tan. So this is what you know, the sine, cos, tan, right? So the sine, cos, tan is the way of telling these things. So these are the longer names, but we use sine, cos, tan. All right. So these are the three basic trigonometric ratios we used in your syllabus, right? Actually, these are also the ratios between the sides. These trigonometric ratios are ratios between the sides, right? Nothing else. That means we get the side lengths. Like the Pythagoras theorem, we found the side lengths. Likewise, we get the ratio between the two sides. That's what the trigonometric ratio means, nothing else. And the sign is nothing but it is opposite over hypotenuse. All right. So what is opposite then? So you know the hypotenuse is not changing. This is the hypotenuse. This is the hypotenuse of this triangle. Similarly, this is the hypotenuse of this triangle. It can change, right? Because it can't change because it is always opposite to the right angle. So for this one, the triangle ABC, since we are considering these acute angles, for this angle, see, this is the opposite side. This is the opposite side. This is the opposite side. And this is the adjacent. Adjacent means like if two things are close together, they are adjacent, right? And you might think that this also can be adjacent. Yes, it also an adjacent side because it also connect at one vertex to make this angle. So it also an adjacent side, but it is a special side that is hypotenuse. That is not changing, but the other side is adjacent. So this cannot be adjacent. Why? Because it is opposite to the right angle. So this should be hypotenuse. After naming the hypotenuse, we name the adjacent side. Understood? Then the opposite side, vice versa. Right. For this angle, this is the opposite. This is the opposite. This is the adjacent. See, with the angle also these sides change. And even in this triangle, if I consider an angle here, let me take it as y for here. So for this y, this is the opposite. This is the adjacent. With the angle, these sides change. So this two pair of sides depend with the angle we select. Alright? Okay. So I told the sine equals opposite over hypotenuse and cos equals adjacent over hypotenuse. Adjacent over hypotenuse. Similarly, tangent equals opposite over adjacent. This will be not given in your paper. In the formula sheet, you will not get this one. So you have to keep in this your mind. And to remember this one, we use this simple saying, the CAH TOA. You might have heard it before. CAH TOA, to memorize these three trigonometric ratios. The S represent the sign, S represent the sign, O represent the opposite, H represent the hypotenuse. So mean sine opposite over hypotenuse. C represent the cos. This is cos adjacent over hypotenuse. T represent the toe, T opposite over adjacent. So this is sine, this is cosine or the cos, this is the tan. This OH means opposite hypotenuse, like that. You can remember this like this. Alright, so these are the three ratios we have. Then we'll apply these three ratios for this particular triangle. Okay, let's use a sine rule. So we write like this: sine x. We write the sine value for the angle because we know with the angle these sides change. So we use this sine value for the angle. Sine x equals what? We know sine is opposite over hypotenuse. What is opposite? AB over hypotenuse is AC. That's it. Then cos x is what? Cos x. Cos is nothing but adjacent over hypotenuse. For this x, this is the adjacent. BC is the adjacent. Hypotenuse is AC. It is not changing. Then what can you tell about the tan ratio? I will write it here. The tan x equals what? Opposite over adjacent. Again, this is opposite. This is adjacent. That is AB over BC. This is the AB over BC. I am again mentioning that these are side lengths. If this side is 10, you have to write 10 for the AB. That's it. Okay. Nothing else. These are sides. Now you can write the trigonometric ratios for this triangle also. That is your assignment. Okay. So while writing this note, you can write the trigonometric ratios for this particular triangle, the PQR, for the angle Y, or else if you can put another angle here, write the trigonometric ratio for that also. This is how it works. Okay, we'll discuss equations based on the trigonometric ratios. So I will get a triangle like this, the triangle ABC, and we have the angle X here. I will give a value here like 60 degrees and this as 10. So the hypotenuse is 10, the angle is 60. My question is find BC. Find BC. Find BC length. Okay, BC means the BC length. The length is given here in centimeters. I will write this is 10 centimeters. Right? Now pay attention. So here we have these ratios put, right? That means the sine ratio means opposite of hypotenuse. We know we have three things. One is the angle and two sides. That means we have to decide what ratio you have to use to find this BC length. Since there are three things, if we know two things, we can find the remaining one. That means if we know the angle and one side, we can find the other side. You know that. So angle is given, that is 60. Another side is given, that we have to find the missing side. Now we have to see, angle is always there, isn't it? Since we asked to find the length, the angle is given, but if the two lengths are given, we can find the angle also. That is for the next part of the lesson, that is inverse ratios, right? But here the angle is given and one side, and this side is hypotenuse because this is opposite to the right angle. So this is what? To this angle, this is adjacent. This is adjacent. So we know hypotenuse and adjacent. If we know the hypotenuse and adjacent and the angle, one ratio is completed. What ratio you have to use? Since you have to find the adjacent side, you know the hypotenuse. We have this adjacent, hypotenuse, and the angle. That means you have to use the cos ratio. That I can write the cos 60. Cos 60 equals what? Adjacent. What is adjacent? BC over hypotenuse is nothing but AB. AB. Then I will again write cos 60 equals, we need the BC, AB value is 10. AB value is 10. Okay, we'll make the BC the subject. That means you have to take this 10 to other side, right? In maths, there's nothing called taking the numbers. What we do is we multiply this by 10, we multiply this by 10 to cancel this logically. But for easy, we tell that the division is there. When we are taking this here, it becomes multiplication. All right. Then the BC equals what? Cos 60 times 10. When this was here, right? Then I changed the two sides. I took the BC here and these two other side. Cos 60, get the cal, press the cos button, enter the 60, cross the brackets, get the value, that will be 0.5. Okay, cos 60 is 0.5 or half. Then half into 10. 0.5 means half as a fraction, you know. Then this equals 5. 10 divided by 2, then the BC value, I will write it here. Then the BC equals what? 5 centimeters. So this will be 5 centimeters. You will get decimal values, right? Cos 60 is 0.5, I can remember that. But it is a decimal, always less than 1. Alright, it is always less than 1 because when you are drawing the cos graph, in future you will draw a graph like this. This is 1, this place is 1 actually, the max value. This is -1. This is 0. That means you can get the negative values also, but that should not exceed the 1. Okay? It can be negative. All right. So that's how you get the cos values or the sine values. If you have been asked to find the AC, you have to use the sine ratio here. Sine AC over hypotenuse. That's how you do practice the questions. Okay, I'll do another session basically discussing the past papers, IGCSE past papers to get the, to practice the practical approach of these theories. All right. So this is the three basic trigonometric ratios. Then next we have to talk about the inverse trigonometric ratios. Right. I will erase this section. That means opposite of this. That means if two sides are given, we can find the angle. Tell me this. What happens when we take the reciprocal of a value? Like how can you write the 1 over sine uh, when we are taking the sign to the denominator, or when we take the reciprocal, what will happen? You know what reciprocal means? That means we are taking the denominator to the numerator and numerator to the denominator. So when we are taking this here and this down, it will become sine inverse, right? Sine -1. Let me show how this happens. Okay, I would say there are three basic inverse ratios. One is sine inverse, cos inverse, and tan inverse. We read this as sine inverse, cos inverse, and tan inverse. Right? That's how we read this. So actually what is happening is, let me take this example here. Okay, I will take this example here. So imagine now the angle is not given. This is x. This is x. I will draw the same triangle here. Okay, this is 90 degrees. This is ABC. This is x. This is what I want to find. And two values are given, 10 and 5. I want the x. What do you use? Here, hypotenuse is given, adjacent is given, x must be found. Then you have to use the cos. There is a cos. Forget about this inverse first, right? Now I will write, I will keep it, pay attention to this section, okay? I will write the ratio that cos x equals what? Cos x is nothing but, that is adjacent over hypotenuse. Adjacent means BC, that is 5. Hypotenuse is 10. I want the x value, isn't it? I want the x value. So I have to make the x the subject. X is the angle value. See, cos 60. Now this 60 is the x. Okay, that means I have to take this cos to the other side. Or else I have to divide the both numbers both side by cos. I will rather say that I will take this to this side. Okay, then x equals what? Sorry. Then I will rather than taking it after the number, I will take it to the beginning. This will become 1 over cos times 5 over 10. This 1 over cos is within nothing but cos inverse. So this is what we have, and we write it directly like cos inverse. Cos inverse of this usual dot is a multiplication like this. Right? In your cal, use the shift and cos inverse you have above the cos button. Then what you have to do? Press the cos inverse, put 5 over 10. Then 5 over 10 means nothing but 0 0.5. 0 0.5 you get the 60 because this is nothing but 60. Okay, so you get x equals 60 degrees. So this is how the inverse functions work. I took the cos as the example, but for the sine, tan, everything you will get the same thing. So this is what inverse means, nothing else. All right, I hope you can understand that one. Okay, so these are the trigonometric ratios we have. Then I told you I'm going to discuss about the bearings and angle of elevation and depression. We'll discuss that also. All right. Okay. Let me erase this. So the angle of elevation is and the depression is used in your paper to make the questions a bit harder for you when actually, especially when you are discussing when you are answering the trigonometric questions. Think like this. You are on a building like this, high story building, skyscraper, next to the sea, like this. There's a flock of birds flying near the trigonometry in the sky, and there's a ship. Oops. Ships like this, yes. I would draw like this. This is your ship. It's like a boat, isn't it? So I would take this is the horizontal line. Is it horizontal? No. Okay. Something like this. Okay, with that. Then this person is looking up at the birds and looking down towards the ship. So with this horizontal line, this is the horizontal line. Okay. In some cases you might say eye line, but we don't consider the height of the person, right? So that's why we name it as horizontal line. Okay, let me name this as angle x. This as angle y. or you might use some definite symbols like theta or alpha, whatever it is for the angles, the symbols. All right. So this is called the angle of elevation. This is angle of elevation. This is the angle of depression. This is the angle of depression. Looking down, depression. Looking up, elevation. So it is measured with relevant to the horizontal line. From this line, if you look up, that is the angle of elevation. If you look down, that is the angle of depression. So these two terms, you should know this one. And this one should be, you should know these two, because in the paper, these terms are there. All right. So you should know these terms to answer the questions that I am giving this one here. The topic should be angle of elevation and depression, right? Write the topic, then write this one as a note. Will be used that in the questions. Okay, the next one I mentioned is the bearings. You might have learned bearings before, right? I will give a brief introduction because the bearings are used in the trigonometry too. It is something like this. Bearings. Okay, that means we have to consider the these four directions: the north, south, east, and west. Okay, the bearing is always measured in the clockwise direction. What is clockwise means? The clockwise means this direction where the hands of the clock rotates. Okay, this is the clockwise, and this is anti-clockwise, other side. So we always measure the bearings in clockwise with relevant to the north side. We always start in from the north. We always started from the north line and measured clockwise, and we always use three figures to write the angle. That means if the angle is 30, we write 0, 30. We don't write 30 degrees, we write 0, 30 degrees. We use three figures always. Okay. Angles more than 100, no issues. It is already three figures. Okay. So let me show you one example. So let's take, this is the point P. This is the point Q. I want the bearing of Q, listen carefully, the bearing of Q from P. From P, so starting here the north line, this is the Q, this is the bearing. This is around 280 degrees, because 90, 180, 270, bit more, 208. This is bearing of Q from P, right? Or else you can write the bearing of Q from P is 280 degrees. Or else this is a point A, this is a point B, like this. This is the bearing. It is around like 40 degrees. How do you read this? The bearing of B from A, right? The bearing of B from A. That's how you write that. Okay, that's all about bearings, the elevations, everything, but we have to practice the question. That will be another video. So I'll be discussing questions based on the 2D trigonometry first. Then we have to go to the 3D trigonometry. This is the theory you should know. From this, we have to do the applications. We have to practice the questions. Not that hard. Okay, we'll do that in the next video. Okay, subscribe.